try to solve one more. So I hope you have seen this question. Let's try to solve this. Consider an angle modulated signal, and this is just a notation for angle. So this can be a PM signal or FM signal, but we are not bothered about that. We just want to know that what is the maximum frequency deviation and maximum phase deviation of this angle modulated signal. So if you remember that any angle modulated waveform can be written as AC cos theta it, right? And you can further write it like this. And for FM scenario and PM scenario, you know that your phi t is 2 pi kf integral of your mu du, and for PM it is kpmt. This value we are talking about this. So any angle modulated waveform will have this form, and depending on FM or PM we can further divide it, but this is not important for this question, as we are only asked what is the phase deviation, maximum phase deviation and maximum frequency deviation. So the instantaneous phase is this, like theta it. So first we write what is the instantaneous phase of the angle modulated waveform, that is given as 10 to the power 6 pi t plus 4 sine 2 pi 10 to the power t. So this is the instantaneous phase of your angle modulated waveform. So what is the phase deviation? If you remember, phase deviation is instantaneous phase minus phase of the carrier wave, that is 2 pi f c t, because our carrier wave is this, right? So phase deviation is 10 theta it minus 10 to the power 6 pi t, and so this is our phase deviation. Phase deviation is this theta it minus 2 pi f c t. So we can write it as 4 sine 2 pi 10 to the power t. So what would be the maximum phase deviation for this? It will be 4 radians, right? Because maximum value of sine is 1. Now our second aim is to find the maximum phase deviation, maximum frequency deviation. We have solved this first. Now we are solving the maximum frequency deviation of this angle modulated waveform. So first we have to write what is the instantaneous frequency. We know the instantaneous phase, so we can evaluate the instantaneous frequency by this formula. And if you solve it, integrate, first we differentiate it and we divide it by 2 pi, we have our instantaneous frequency like this. And if you remember, the frequency deviation is instantaneous frequency of the angle modulated waveform minus the frequency of your carrier. And what is the frequency of your carrier? 10 to the power 6 by 2, this one. So we just write this FIT and we subtract it, so this value will go away and this quantity will be remaining. So frequency deviation is this. So what would be the maximum frequency deviation? The maximum value of this quantity is 1. So maximum frequency deviation of your angle modulated waveform will be 4 kilo